Hello everyone, we are Group 5 in CE14B2. We are conducting an experiment on reduction of sample size by quartering method and determination of specific gravity, water absorption, moisture content, and densities of fine aggregates.
Weigh the empty containers on a weighing scale and record their mass. Obtain the height, width, and length of the container. To start reducing the sample size by quartering method, place fine aggregate sample on the mixing pan. Using the shovel, mix the sample by turning it at least 3 times, forming a cone. Flatten the pile by pushing it down with a shovel. Divide the pile into quarters and discard the diagonally opposite quarters. Repeat these steps until the desired sample size is achieved. After quartering method, sieve the sample using sieve number 4. The sieved sample should be placed in the 6 sample containers. Choose 3 samples out of 6 to be saturated with water. Make sure that the sand absorbs the water, then remove the excess water. Weigh and record the final mass of the 3 dry samples and 3 wet samples. Label the containers with their sample number, category, group name, and section. Put the wet and dry samples in the drying oven for at least 24 hours. After oven drying, record the weight of the sample after immediately getting it from the drying oven. Cool the sample for 1 to 3 hours at room temperature. After the cooling period, wash the wet samples and immerse the sand in water at room temperature for a period of 15 to 19 hours. After that, remove the samples from the water. Spread the samples on a flat, non-absorbent surface. Stir the sample occasionally to assist in homogeneous drying. After, put the samples in the drying oven for at least 24 hours. After oven drying, record the weight of the sand as SSD mass. So here are our gathered data. Table 1 shows the dimension of all the containers with their mass, length, weight, and volume. Table 2 shows the masses of the fine aggregate samples that are already divided to wet and dry samples. So to get the mass without container, simply subtract the mass of the container from the mass of the sample with the container. Table 3 shows the determination of water absorption, with sample A having 1.35% water absorbed, sample B with 3.95% as the highest, and sample C 1.11%. Table 4 and 5 shows the weight specification of the samples and the determination of bulk SSD and apparent specific gravity of samples. Lastly, Table 6 shows the determination of normal and bulk density, in which sample B got the highest result of 1.151 in normal density, followed by sample A with 1.029 and sample C with 1.022, and all of these yielded an average of 1.07. Likewise, for the bulk density, sample B yielded 1.167, sample A with 1.056, and sample C with 1.045, and all of these three got an average of 1.089.